All right, here's the, let's see what happens. See if it blows up or not. And I said yesterday, what did I say about limits? Not to miss today. They're gonna be the ones that's gonna be hurting. Oh, we got a little cabinet over here. And guess what?
So,
There's always something wrong there.
I think it's on the other board over there.
Oh, the little box.
Yeah.
They're not perfect, they're not messed it up.
Don't take any strand of magnets inside of the desk for me.
It's like it's asking me to. Really? Not again. So this is supposed to be the, wait a minute, I think I'm gonna get this to do this. I can get it to do, yeah. There we go. It'll work, it should work. It'll work. You don't have to excuse me, I'm really pissed right now. This is so ridiculous. And this is the main campus. This is. Okay, this is what we're gonna do. We're gonna try to make it. It's kind of frustrating when, well, I am the only one that records, so I am in the minority. So, limits. What is a limit? Well, think of a limit as I usually draw this out, but think of a limit as taking a full side step toward a wall. And each time you take a step, you take half of the previous step. Okay, I don't know what this is. Now, what I'm saying is, if you stand right here at the chalkboard, or whatever this thing is, and you want to take a side step, that means you're facing that way, and some of y'all could do a split, some of you could just do 3 feet. But let's say that you could do an easy number, let's say 6 feet. Let's say you could stretch your legs out to 6 foot span. Everybody with me? Let's do 4. It's easier. All right. And then the next step you take toward that wall is half the previous step. So that'd be what? 2 foot. So let's do that mathematically. The first step is 4 foot. Then the second step would be 2 foot. Then the third step would be 1 foot. Then the next step would be what? Half a foot. Oops, that's a half inch. Half a foot. Then the next step would be 1/4. And then the next would be 1/8. You starting to see the pattern? I can't think about what to, there we go. 1/8 foot. 1/16 of a foot. 1/32 of a foot. 1/64 of a foot. 1/128, y'all help me out, of a foot. 256. So what are we approaching? We're approaching the wall, but do we ever reach it? No. Now, you got to think. Of course, some of y'all are saying, well, how do you do 1/4 of a foot? Okay, this is mathematical. You're thinking out of the box, and you have to think out of the box when you're talking about limits, because what you're talking about is getting as close to that wall like a hair width. Okay? When you're talking about limits, we're talking hair width. We're talking less than a hair width. Okay? So that's what you have to think about. The old days of algebra that you say, okay, this is point 2 and 4. Boom, you put a point. That's algebra. You're starting to make the transition into calculus, which has to have limits. You have to have that approaching the wall but not touching it. You have to have that, or you don't have calculus, because calculus is instantaneous calculations, where algebra is a point in time. All right, 1 point in time, and calculus is anywhere on that line. You can find what you need. All right, so this is a limit. Now, you can do limit several ways. You can do a graphical limit, or you can do an algebraic limit. All right, the way it's written is the following. Limit, well, excuse me, I've got to change. Limit as x approaches some number, let's say 1, of x plus 1. Now this one's real simple. You just plug in 1. So as x approaches 1, x plus 1, and x plus 1 looks like this. It's a straight line, because you know your parent graphs. Wow, parent graphs. It's the y-intercept of what? 1. So you got a line, excuse me. It'd be nice to do with straight lines, but it'd take half a day to get the stuff pulled up to do it. There's your line, and it's going through that point right there. And the question is asking, as x approaches 1, there's x right there. As x approaches 1, as you approach x is equal to 1, and you can do your, as you approach x is equal to 1, what is your black dot doing? It's approaching another number on the y. It's approaching something. So you plug and chug. And this is the easiest of the limits. So 1 plus 1 is what? So the limit as x approaches 1 is equal to 2. So at this point right here, that's supposed to be 2. So we'll make a big dot right there. There we go. Kind of cheat a little bit. That's 2. Okay, now that's what. Now you're talking about a hair width. As I approach 1, I don't actually get to 1. Y is approaching 2. Now the reason you need to know how to do a limit is because when we get to a tangent line, and that's what a tangent line is, when I'll explain it to you, and hopefully you'll get it. That distance between the first x and the second x is approaching 0, like this. Okay, it's approaching 0. and it gets to 0 within a hair width. And I use a hair width because that's about the smallest thing that you can visualize. But actually the limit goes 10 times, 100 times thinner than the hair width. But we don't think that far out of the box. So let me ask you a question. And I'm going to go back to algebra here. We're going to visit, I'm going to show you how the application of the limit works. I want you, and this is review, this is a quick review. I've got to find my straight line maker. There's my straight line. There's my straight line. And I'm going to draw a line like this. And I'm going to put a point here and a point here. And I think this point is probably 0, 2. And this point is -3, 0. I want you to find the slope. Now, a lot of you say, oh, I know how to do it. Well, good. Do it. And if you can't do it, then just meditate on okay, so we all know that the slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And which way do we read? Unless you're from the Middle East, masalama. So that would be, this is the first set, so that's your x sub 1, y sub 1. Masalama means go in peace. What? Yeah, something like that. Dang old mummy. Okay, x sub 2. I love that movie. The Mummy and the Mummy Returns. Yeah, the last one sucked. It didn't have the chick in it. What's her name? I don't know her name, but she's attractive. So parentheses. I'm sorry, what?
I rediscovered Emperor's New Groove. Rediscovered?
What did he say?
Emperor's New Groove?
Good.
It was 90 Babies thing.
I've never seen that.
They're so great.
Is it a comedy? I don't do comedies.
You don't enjoy laughter?
Nope. Oh, I enjoy watching drunk people get tased on YouTube. That's what I like. I laugh at stuff like that.
You should go to Colorado High School.
No, don't have no reason to go there. All right, so what's y sub 2? 2 and 0 and 0 and -3. So our answer is 2/3.
They read left and right.
We do read left to right. So this is x sub 1, y sub 1, this is x sub 2, y sub 2. This is your first point. This is your second point. All right, pre-algebra stuff. Everybody's good to go with that. Right?
Yes, sir.
Okay, now we're going to do another one, except it's going to be different. Let's say we have a curve. I'm going to make this a little bit bigger. Let's say we have a curve that looks something like that. Please, no throwing of notebooks in the classroom, please. She's getting upset. She can't handle it. Stress. All right, so here's a point, and here's a point. I'm going to take my handy dandy straight line maker, and I'm going to draw, and I'll fix it in just a second. Somebody tell me what that line is called. Anybody know? I'm sorry, what? No. Secant. When it's inside the curve, it's called the secant line. So you need to write that down. Dang old secant line. Go away. Now let's take our handy dandy straight line maker. I can't make a dashed line on this dadgum thing. I don't know why. So I'll change it to that color. And of course that's going to be X. Now we can't use Y in this class because it's not sophisticated. So we have to use what? We have to use f of x. So I'm going to take my green line, and that's f of x. And I'm going to take my blue line, and I'm going to take my green line, and I'm going to call this distance right here between x and this point right here. I'm going to call this distance h. So somebody tell me what this point is right here. Well, this is x. No, what is it? Just give me a description of this number. X plus h. Lions and tigers and bears. Oh my. I was the lion in Wizard of Oz in Anderson's play about 2 years ago. Anderson Community Theater, or the Alberson Community Theater. So what is over here? What? F of what?
Plus h.
Plus h. So, could we put these 2 points right here, we could actually give a coordinate to. This coordinate, I'm going to erase a little bit around it so I can put a point. Oops, not going to do that though. Hold on. I'm going to erase a little bit. Really? Okay, forget it. I'm going to put this point is x, comma, f of x, right? Everybody agree with that? All right, that's that point. So what's this point? This point is x plus h, comma, what? F of x plus h. Now I want everybody to find the slope of this line. Got to use a big set of parentheses. Which way do you read? So mark your points, x of 1, y sub 1, x of 2, y sub 2. Just like we did with the numbers. See, I can use the program. I just can't write on the board with it. You are impressed, aren't you? All right, so just like before, M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this point right here is x sub 1, y sub 1. And this point right here is x sub 2, y sub 2. So first thing I do, because I teach all my algebra students, anytime you plug in something, use a what? Big set of parentheses. Of course, when they don't use the big set of parentheses, they usually get the problem wrong because of signs. But they know more than I do. All right, so what's y sub 2? F of x plus h. And what is y sub 1? X sub 2? And x. And what happens to the x's? X minus x leaves just h. So now the slope of this secant line is equal to f of x plus h minus f of x over h. Anybody know what that's called? This formula, yeah. But it's called something. Nope. It's called something, and right now it just left me. But that's to find the tangent. That's to find the slope of the secant line. Well, what's that got to do with anything, Hubert? Well, now, yes. Now, let's use our limit theory, because all this is algebra. Okay? Now let's use our limit theory. Let's say limit as x, I'm sorry, h. I always put x, that's just habit. Everybody uses x, and that's just habit. So sometimes I'll put an x down there, just look over it. H approaches 0. So tell me what happens when h approaches 0. Describe to me what happens as h approaches 0. What's getting close?
The line getting close to the origin.
Which line? Tell me which line. The first blue line or the second blue line? Second blue line. Because think about it. Where is 0? If you're starting at h and you're ending up at, if you're starting at x and you're ending up at x plus h, which way is h going to be 0? This way or this way? This way. Yeah, because h was added. All right. So if h is going to be 0, then this line is going to converge onto this line, right? So what's going to happen to that dot? Well, that dot is going to move down. I'm going to use the blue dot to show what happens. As this goes this way, let me use my, hold on. As I move h this way, that blue line, that dot, that red dot is going to hit here. And then it's going to hit here. Okay, there's your 4 foot, there's your 2 foot, there's your 1 foot, there's your half a foot, there's your 1/4 of a foot, till it gets to what? A hairline beside that red one. And when you get that close, your secant line turns into what? Not straight. Nope. What does it turn into? Tangent line. And see, that's what calculus is all about, finding the tangent on a curve. So now we can take this. We can take our handy dandy M and erase it and slide this in right here. Really. And now you got calculus.
Alright, so we do the other stuff again as you move down.
As this moves this way, as X moves this way, this red dot moves down here. And I use the analogy of walking halfway, halfway, halfway. And eventually you get to a hair width from that red dot down here. And when you get to that point, you've turned the secant line into what? The tangent line. And that's what calculus is all about. Now, you got to know how to work this, and you got to know how to work the limit. So but that's where we're going with it. And when we get through today, Monday of next week, we'll be ready to start showing you how the algebra and the limit together does the same thing as the derivative in calculus. And then we'll put the two together. All right? So, there's three types of limits. There is the limit, and these are just problems that you might see in homework or the test, and I just did one for you. Limit as x approaches 5 of x squared minus 4. Okay, so what do you have? You have a parabola, right? And you know it's a parabola because you know the last section of what we went over. What's the y-intercept? -4. Oh, we don't know we don't know where the x-intercepts are. Oh, we can use completeness square. X squared plus 0x minus 4 is equal to 0. All right, start it. Now, the reason I put the 0x there is so you can go through and do everything that you're doing. It may be elementary, but you won't be sitting there staring at it for 15 minutes.
Is that secant formula called secant method?
No, it's called, the reason I've got it mixed up with something, I've got it mixed up with the difference quotient, but I thought it was called the difference quotient, but that's not it, I don't think. I'll have to look it up because I can't remember what it's called. Let me look. Look in the index and see if you see a word called difference quotient. No, this book sucks. It ain't going to be there. Let me just look it up on Google. Yep, that's what it is. It's called the difference quotient. There it is. Mm-hmm. Oh my, look there. Dang old, there's my drawing. I'm just awesome. No applause.
I got the positive and negatives here for the x-intercepts.
That sounds good. And you could have easily solved it by moving the 4 over and taking the square root. I just wanted you to use complete the square. So positive or negative 2 So we got that, and positive 2, and negative 2, and our vertex. What does somebody tell me what the vertex comes out to be?
0, 4.
Okay, it's the same thing. It's the same thing. That's what I thought. All right, so this is our parabola. And limit as x approaches 5. Well, 5, 2, 3, 4, 5. Here's 5. So let me take my handy dandy straight line maker. 5 is like right in here. 5 is going to be way up here somewhere. There's 5. So I have no idea. So since I can't tell graphically, let's do it algebraically. So we go do it algebraically. Be 5 squared minus 4. Well, what's 25 minus 4? Yeah, 5 squared is 25. Minus 4 is 21. So we know that our green line up here, even though we can't see it, I'm sorry, that's 21, because that's where this parabola goes, right there. And see, therefore, you don't have to graph a half a page to find where it approaches, because you can do it algebraically. That's why we do it algebraically. Now, you should be able to do it graphically. The other method is graphic. If I give you a line or a parabola and it looks like this, and I tell you as x approaches 2, you'll tell me it approaches what? 4. So you should be able to do that, okay? Because that point right there is 2 and 4. All right? And then there's the other ones, okay? The other ones are a little bit more complicated. Limit as x approaches 2 of x squared plus 4x plus 4 over x minus 2. Now, when you look at this one, what do you think? Plug in the 2, right? Well, when you do that, you get an undefined function. So you put undefined and keep on going. Nothing is that easy in calculus, okay? If you think something is that easy, then chances are you need to go back and do something else. Okay, what's on top? A trinomial. Trinomials are worthless unless you what? Factor them. So factor it. I must have a hot bite because I've got a real estate agent call me. I'm selling some property and I think he must have a seller. He done called me like 3 times in the last 5 minutes. I hope. I need dang old money, dang old broke.
So x plus 2 squared, right?
Yes. X plus 2 times x. Oh, shoot. I messed up. It's supposed to be, hold on a minute. I messed up. I suck. Go from awesome to suck in 5 minutes. X squared minus 4. How about that? That's better. Shortcut number 3. Yeah, thought I messed up again. What's the square root of 4? What's the square root of x? Squared. X. So x plus 2, x minus 2 over x minus 2. And what happens to the x minus 2's? And now you can do the limit. So there's three types of limit problems. There's the ones that's easy to do, that you plug in a number and it works. Then there's a graphing type limit, and then there's this type. So x plus 2, x minus 2 over x minus 2, and your x minus 2's cancel, and now you have the limit as x approaches 2 of x plus 2. And what happens at x plus 2, when it approaches 2, you're approaching what number? 4. So the limit as x approaches 2 is equal to 4. Now you got to realize what this looks like. Well, you know your linear graphs, or go ahead and graph. I'll tell you what, go ahead and graph this on your calculator. Because you need to graph it. It's going to be kind of funky. It's going to have a saddle in it probably or something. I don't know. Yeah, probably a little bit of a saddle. While you're doing that, I got to pull up my handy dandy virtual calculator. And I get y is equal to, parentheses, x squared minus 4 divided by, parentheses, x minus 2, close parentheses, graph. Okay, now, it's probably not going to show it, but I'm going to do you can go to window, and I want my x min to be -3 to +3. Don't use the keyboard, Hubert. Hold on a minute. You see, I don't use the calculator very much. Don't use the keyboard. -3, +3. And then I'm going to make the -5, +5. I'd leave 2. Now, you don't see it on the graph, but go to your second table, or second graph. Look at that. What happens at 2? What does that mean?
It's not there.
Why? Why is it undefined? I'm asking you why.
Underneath the denominator, so it doesn't exist.
Yeah, you can't have 2. So what should go here at that 2? An open what? An open circle. So I'm going to take my handy dandy circle maker and, oh, I'm sorry, hold on. There we go. Take my handy dandy circle maker and we'll make it black to make sure it, there we go. And I'm exaggerating a little bit because so you can see it, but at x equals 2, there should be a open circle right there. All right. Now, as x approaches 2, what is it approaching on the y? 4. 1, 2, 3, 4. Does it ever touch 4? No, because you can't use what? 2. You can't use 2. You can use 1.999 and you can use 2.001, but you can't use 2 because 2 blows the function up. And that's the 3 sets of limits. I mean, that's the 3 limit problems. Now, yes, you're going to have discontinuity and continuity and all that, but that to me, that's not important. What's important is that you understand what the limit is. Because if you understand what the limit is and how it approaches something, then you understand the secant line turning into a tangent line. And if you understand that, then you're going to understand calculus. Okay? So when I pick these limit problems, I'm going to pick them specifically to what I just went over. But I want to move on to some more of the difference quotient, because when I give you the difference quotient problems, you're going to do probably 25 or 30 of them. All right? Because it's very important that you understand what that difference quotient gives you. So let's move on to the difference quotient. And I promise you're going to thank me, because you're going to see how blessed we are to have calculus after you work a few quotient problems, difference quotient problems. It's kind of like the trigonometric table versus the calculator. Thank God for the calculator, because the trigonometric table was awful to use. I came in after the trigonometric table, but I had teachers that made us go back and look at it, and it was a pain. So here we go. I want you to tell me f of x, where the slope, where the tangent line is, or the secant, tangent of the secant, I'm sorry. The slope of the secant line of f of x is equal to x squared plus 6. Okay? And then I'll show you what it means after we do it. Now, some of y'all are going to say, okay, what do I need to do? First of all, graph it. Sketch it. Now that you can sketch it. And what's the square root of -6? Well, it doesn't cross the x-axis. So, but you do have the y-intercept. The y-intercept is 6. So it's floating. Yeah, just leave. So you've got a graph. Oh, that's the wrong thing. Straight line. There we go. Sorry. X plus 6. So that's right in there. It's not crossing the x-axis, but if you was to use completing the square, it's going to be -6, probably. Let's see. Let me look. Somebody get the vertex. What was it? Okay, nobody's going to answer. So x squared plus 0x plus blank is equal to 0, or -6 plus blank. Half of 0 is 2, 0, 0, 0, all that's added, that would be x plus 0. Be the same thing. X plus 0 is equal to 6. X plus 0 quantity squared is equal to -6. The opposite of -6 is 6, so it's going this way. Like that. And we want to know the slope of the secant line at any point on this, or the tangent line, I'm sorry, at any point on this, or the secant line, any point. So let's just pick a point right here. Okay? So you don't have to have any numbers because we're not going to use any numbers. Here we go. So our formula is limit as h approaches 0. That's going to be every time you do this difference quotient of f of x plus h minus f of x over h. Now what are we going to do right here? Nope. What are we going to do there? Well, what if that said f of 3? What would we do? Use 3. What does that mean? Take 3 and do what? Plug it in. But it's not 3. It's x plus h. So what are you going to do with x plus h? Say again? Plug it in. So we're going to rewrite this with big set of parentheses. And what is f of x? F of x, which I'll color that green. This, we don't have to do anything because that's what we're given. We just put that in there. This is f of x. So it just goes right here. I'm going to put a set of parentheses here too. So I'm plugging in. Yes? What do you mean? No, you got to take this and plug it in. We're going to composition. That's what we're doing. So limit as h approaches 0 of parentheses squared plus 6, and I'm going to put that in brackets because that's your x squared plus 6, plus another set of brackets. I'm sorry, minus, minus x squared plus 6 in brackets, all over h. And what I'm going to do is I'm going to take my handy dandy highlighter and I'm going to color this that color. And this right here, I'm going to not put, we'll put x plus h right there, sorry. There we go. I'm going to color this aqua. And that right there is going to be that x plus h right there. All right, do your algebra, because all this is algebra. Dang old shortcuts. Do not apply the limit yet. Do not do that. Just get it down to the simplest form. When you get it down to the simplest form, then that is your slope of your secant line. When you apply the limit, that's going to be the slope of the tangent line. I've got to get rid of all this because I got to make it smaller.
I must have played catch up or something, but I don't know how you got plus 6 for.
Look at the.
Where you dragged it from.
Okay, hold on. All right, what's your equation?
Square plus 6.
So if you was to plug in a 3, what would you do?
9 plus 6.
Well, it'd be 3 squared plus 6, right? So we're not plugging in a 3. We're plugging in what?
X plus H.
So what would it be? plus 6.
So h equals 6.
This is x squared plus 6. Wherever there was an x, what did I do? I plugged in x plus h. Just like if you would do a 3.
But I'm talking about the 6. I'm not talking about x plus h.
Well, the 6 comes from this. There's the 6. X squared plus h. X squared plus h. Yeah, no, h is not equal to 6. This is x squared plus 6. X squared plus 6. And this is just f of x. F of x is x squared plus 6. After about the third problem, you'll get used to it. So we got to use our handy dandy algebra. Shortcut number 1. H approaches infinity. I'm sorry, h approaches 0. You got to watch me on that. That'll be x squared plus 2xh plus h squared. I'm going to put little parentheses around that because that's the trinomial, plus 6. We can't add that to anything, but minus, distribute the negative, minus x squared minus 6. All that's in brackets over h. Oh my, look what happens. What happens? The 6 does what? And the x squared, is that supposed to happen? Yes. The only thing you should be left with is terms of what? H. You might have an x somewhere by itself, but that's fine. But most of your terms should be h when you get finished. Now, I got limit, limit as h approaches 0 of 2xh plus h over h. Now, does anybody see anything in common on the top? H, so factor that out.
Wait, isn't that h squared?
Where? Yeah, thank you. Thank you, thank you, thank you. So that would be an h right here. Over h. And what happens to the two h's by themselves? This cancels. So, the slope of the secant line is 2x plus h, but we don't care about the secant line. H approaches 0 of 2x plus h. 2x plus h, that is the slope of the secant line, but I don't care about that. So what do we do when we want to find the limit algebraically and h approaches 0? What do you do? Plug in 0 for what? H. And we get what? 2x. Well, what is 2x? Well, I'm fixing to show you. Any point on this line, I picked this point right here. So I'm going to take my red line maker. This right here is the equation. Write this down. The equation. This is the equation for the slope of the tangent line anywhere on this curve. Oops. The equationing. That 2x is the slope of this line. Well, how do you know that? Well, let's take our handy dandy. Let's say this is x is equal to 3. Let me drop a line down. Let's say this is 3. What's the slope of this line if at x is equal to 3? Well, 3 times 2 is what? So the slope of this red line is 6 over 1. Let's take the blue marker and let's put one right here and draw a blue line. That line right there, what's the slope of that line? Well, let's say this, hold on, I'm trying to do this in different colors where y'all can see, okay? Let's say that's -1. Well, what's the slope of that blue line? Slope of that blue line is negative what? 6 over what? I'm sorry, 2 times -1 is negative what? 2 over 1, sorry. I had a brain bubble there for a minute. Negative 2 over 1. Somebody tell me what the slope is at 0 at the vertex. I'll draw a brown line. No, let's draw something. Let's draw a green line. What is the slope of that line right there? Well, let's check it. At 0, 0 times 2 is, what about that? So you've just applied the limit to the algebra. Let me ask you something. How much of this is calculus? None of it. What is most of it? Algebra. If you suck at algebra, you're going to suck at calculus. You've got to review that stuff that we went over a while back, especially those shortcuts. Those shortcuts, if you can't do them, you might as well hang it up. Okay? Yes, sir.
Is that the derivative of?
That's what we later call the derivative, yes. But now you see what it is, instead of me just showing you. Because the derivative of x squared is 2x. And we're going to get to that after y'all do 50 of these, 50 or 60 of these quotient. I'm just kidding, chill. All right, you ready to work? F of x is equal to, and the reason I also give a lot of these, if you don't suck at algebra, if you suck at algebra before this homework, you're not going to suck after this homework because you'll learn it, or you won't do it, one of the two. F of x is equal to x squared plus 2x minus 7. Now I want you to draw it first. I want you to sketch it because you don't understand anything until you sketch it and then you can draw the lines on it. And then I want you to find the slope. When you're all finished, I want you to find the slope at x is equal to 2. So there's 2 parts. Well, actually 3 parts. Sketch the graph, then do the difference quotient, and then tell me the slope.
So do we get the remainder of the class on it?
No, because we got another one. You should do this in about 5 minutes.